Good morning, everybody. How are you guys? Everybody doing well? Great. Well, some people may straggle in because this is the first session of the day, but we'll go ahead and get started. So, for 4,500 years, books were copied by hand. We had books of law, philosophy, religion, great tragedies, comedies, all copied meticulously on papyrus, paper, wax, a variety of different materials. The invention of movable type and the printing press changed all of that. Now we could create a page once and then use that same design multiple times in order to print multiple copies of the book. And it opened up books to the common people. It encouraged education. It encouraged distribution of those books. In fact, one of the studies that I saw said that prior to the printing press, we had about 50,000 books in circulation. Within 50 years, there were over 10 million. It was a huge change for society. And I think in some ways, iOS has provided some of that same sort of motivation. I'm going to take you back in time just a little bit to 2007 and the original introduction of the iPhone. Apple introduced the iPhone, had a single device, single size, 320 by 480 resolution. In 2008, we had the App Store, and the mobile revolution began. Developers began targeting those screens, creating pixel-perfect displays for a 320 by 480 display, or perhaps a 480 by 320 if you tilted it on its side, and began creating applications. In 2010, the world changed again with the iPad. Some people called it the big iPhone. It was mocked a little bit. However, they created another market. In fact, I have a Microsoft Surface tablet and an Android tablet. You know what my kids call them? An iPad. Say, can I play with the iPad? Right? That's how vernacular that has become in the marketplace. And developers could just run their phone apps on the iPad. So Apple was nice enough to provide a legacy mode, but the apps look horrible. And so most of the time, they recreated their application designs for the iPad in a 1024 by 768 resolution. And so now we had two different screen sizes to deal with. Well, the way that most developers handled that was one of two approaches. They could either completely rewrite the application and have two separate apps, one for the iPhone, one for the iPad. Some developers chose to do that. It's very irritating to have to buy an app twice. Some of them chose to use the universal application template. This is a template that Apple created specifically so that we could have one binary get distributed to both platforms, to both device form factors. And the way it worked is we had two different views where we would design the actual visuals for our application. We had a storyboard for the iPad and a storyboard for the iPhone. Now, of course, the goal of the universal application was to share some of the logic. And so the way this worked is we would have a single view controller to drive that logic. Now, if you're not completely familiar with the way iOS works, the view is described typically in some sort of declarative form. We had a couple different ways to do it. We had the nib files, or zib files, as some people will sometimes call them, where we would describe a single screen, and then we had storyboards to describe multiple screens. The view controller is the logic that derives those screens. So it's, to some degree, the behavior of the application, if you want to think of it that way. And when we share that view logic inside the view controller, you would typically sprinkle your code with a bunch of statements that look like this. This is Objective-C, by the way, if you're not familiar with it, where we would say, what is the device idiom? Is it an iPhone or an iPad? And if it's an iPad, we do this, and if it's an iPhone, we do that. So we would interact specifically with the view elements that were created for that storyboard so that we could then tailor the logic to drive either the tablet or the phone display. This works. A lot of developers went down this road. The problem that we've run into today is we have a lot of devices. Right? Everything, if we just consider iOS 8, from the iPhone 4S all the way up to the iPad, with lots of different resolutions in between. To some degree, we're beginning to face the same sorts of UI fragmentation problems that Android developers have had for years. And so don't expect any sympathy from the Android guys. You know, if you go to them and say, man, I've got to write for 5 different resolutions, they're going to laugh at you, okay? And one of the goals of iOS 8 in particular was to be able to address this problem of trying to make sure that our UI works with all kinds of devices. And that's really the topic that we're going to talk about today, is adaptability. So this is designing adaptive applications for the iOS platform. My name is Mark Smith. I actually work for Xamarin, which is a mobile developer company. We build cross-platform tools that allow you to take skills that Microsoft developers know, such as C# and XAML, and apply them to iOS, Android, and Windows Phone development. But I'm actually not going to be looking at Xamarin stuff today. If we have some time towards the end, I might pull it up just to show you the similarity. We're actually going to be using the native tooling from Apple, because a lot of the APIs that were introduced, and in particular a lot of the UI paradigms for the UI design itself, were obviously created by Apple. And so we're going to look at the native side just to see how it's all put together. But be aware that all of those same techniques can be applied on the Xamarin side. So if you're a Xamarin guy and you'd like to be able to use C# to build your application, that's great. I think that's a smart move. And you can totally use all of the things that I'm about to show you in that world as well. But we're going to be focusing primarily on the native tooling, specifically Xcode. And so where I'd like to start is actually a quote that comes right out of the What's New in Xcode 6 documentation. Now, I've paraphrased this quote slightly, so if you directly search for this, you won't find an exact match. And I've also highlighted a bit of it just to sort of tease out some of the meaning that's in here. But they basically said, adaptive design allows developers to design a single universal storyboard with customized layouts for both the iPhone and iPad. You can define common views and constraints once, and then add variations for each supported form factor. The idea is we're going to not just share the code, we're going to share the view as well. So rather than defining our views multiple times for a bunch of different device form factors, we're going to create a view once, and then we're going to apply different variations to that view to say, when we're running in this style, I want it to look this way, and when we're running in this other platform style, I want it to look that way. Okay? Now, we're going to be focusing predominantly on iOS 8 features. Apple touts that iOS 8 has over 4,000 API changes or additions to the platform. That's a lot. It was a huge release. And I would argue that the majority of those changes, there you go again. They just wanted to interrupt me. I would argue that the majority of those changes were actually related to adaptive design. Now, we're obviously not going to have time to go through all 4,000 APIs, and frankly, even if we did, I don't think I could stand it, much less you. I can't listen to myself that long. So we're going to be focusing specifically on some of the tooling changes, in particular in Interface Builder. And so we're going to be doing a lot of declarative things in storyboards, and I'm going to show you sort of some techniques and strategies that you can use in order to kind of design your UI specifically within storyboards to be able to do adaptive design. All right, so what were the things that changed? Well, first, in the tooling itself, when you pull up Xcode 6, one of the things that you'll notice that's very evident is there are no longer universal projects. So when you create a project, you will not see iPhone versus iPad anymore. Instead, you'll just see the specific project types: master detail, page-based, single view, tab, and then a game application. So there's no evidence of an iPhone app, an iPad app, or a universal app anymore. It's just an app. The second screen that gets displayed will then let you choose a particular device form factor, the default being universal. So they're sort of pushing you down this path of creating applications that can target multiple devices. Why is that important? Well, clearly we have different iPhones and iPad sizes, but even more realistically is down the road, we're going to see even more devices. So we have the watch coming out. This is not an Apple Watch. But we also have, I heard a rumor, which we've been hearing for years, but at the Worldwide Developer Conference, they're going to refresh the Apple TV. And one of the things that they plan to put in it is app support. So we can now build apps, or we supposedly, we'll see, be able to build apps for the Apple TV. There's also, of course, the rumor of the 12-inch iPad, so that'll be even a bigger resolution. So we've got lots of different form factors that potentially will be coming out in the future. Apple's beginning to leverage their APIs and their tooling to push us in that direction to prepare us for that, so that we're not rewriting our apps multiple times. So we now just do universal applications by default. We pick the application style, we then kind of move in. The second thing that you'll notice when you create an app is there's one storyboard. We no longer have an iPad storyboard and an iPhone storyboard. It's still a universal device, so it supports all the different devices, but does it with one view. Okay, so we'll design that view once. So let's just look real quickly at kind of Xcode and the creation of a project and what it looks like. So I'm going to pull up Xcode down here. And I'm going to create a new Xcode project, and I'm going to just build a single view application, and we're going to call it my universal app. Okay, and we'll just put it on the desktop. So when I go to the main storyboard, notice there's just one, and I click on it, it puts me in Interface Builder, and let me just close one of the views here to give myself a little bit more room. Notice something interesting about this view. It doesn't look like an iPhone, and it doesn't look like an iPad. In fact, it's just a square view. Okay, so this is the new visualization for the storyboard with just a square sort of presentation. It's like 600 by 600 or something along those lines. I can still tell it to render in a different way. So when we select a view controller, I can go to the properties here and pick the size and say, well, I actually want it to look like a 3.5-inch iPhone, or I'd like it to look like a iPhone 6, or maybe even an iPad. So I can pick a specific device style, and it will then change the storyboard size to reflect that. That's just a designer size. We're not actually changing anything about the application being generated. It's just the simulated metrics. So it's kind of giving me a design surface that reflects that particular device. If I truly want to make this only target a specific device, I can do two things. One is I can go to the project properties, and I can change the devices here and say I just want it to do an iPhone, or I just want to do an iPad. That may be appropriate if I'm only building for a tablet, for example, or I don't want to use a tablet. More likely it's that you would target a tablet specifically. The other thing that I could do, let me go back to the storyboard, is I can turn off in the storyboard itself something called size classes. And so here on the document section, there's two flags that are over here that we can sort of influence. One is use auto layout. So that's been there since iOS 6. That's the constraint-based system. We're going to look at that in a little bit. The second is new. This is size classes. We're going to talk about these in more detail in just a few minutes. But this is actually one of the adaptive design pieces that's built into iOS 8 and into Xcode. And if you turn off the size class support, it'll say, okay, disable size classes. Which one do you want to keep size data for, iPhone or iPad? If I select iPhone, you can see immediately my design surface goes back to the normal view like it always did. Okay, so this is more reflective of Xcode 5, for example, where we didn't really have this sort of universal storyboard presence here. And then, of course, I can check it again in order to put it back in its original size. And so we can say, let's go ahead and enable those size classes. And now we're back to our square storyboard. Okay? Now, so what does this buy me? Well, let's just put something into the view. I'm going to throw a label in here, and we're just going to put it in the center. So notice Xcode gives me nice guideline markers here, and it says this label is now in the center, except if I actually run it, I'm going to put it on an iPhone 6, you can see that when my app runs, even though it looks like it's in the center in the design surface, it's not really centered at all. Okay? So Xcode, by default, doesn't really do a whole lot for us. It adjusts the frame to a particular device unit location. In this particular case, if we look at this particular label, in fact, let's just do something here. I'm going to grab a class that I've already built. Let me put my File Explorer back on here, and let's just drop this in. And I'm going to take this position label. You can see this is just a really quick Swift file. So if you've not seen Swift, Swift is very reminiscent of early F#. It's a functional language that interoperates very nicely with Objective-C. If you're just now starting iOS development and you want to do native development, you should learn Objective-C just because a lot of samples are in Objective-C, but I wouldn't use Objective-C at this point going forward to write an app. I would probably focus more on Swift. As time goes forward, this is very likely going to replace Objective-C, at least from Apple's perspective. So you can see we're basically creating a UI label derivative called position label. And what I'm going to do is go back to my main storyboard, take this label, and I'm just going to change it and say I'd like to make this actually a position label. Okay, so now the class that's actually going to be instantiated when this storyboard is kind of pulled into existence will be one of these position labels. If I run my iPhone 6 simulation here, cancel, you can see that we have it there. It's at 279, 289. Okay? And it's not going to change. So for instance, if I rotate this display, you can see that it's still 279, 289. That's the frame of that label. In other words, that's its physical position within the view itself, within its own super view. Okay? And so it doesn't get adjusted. Now, the idea would be that I would actually like to adjust this. I would like to get the system to really center this. So it was a little bit, misleading that it showed me centering here when it really didn't do any centering at all. This is just a fixed location. In fact, I can see that if we go here to the layout section, you can see there is the 279, 289. Right? It's just a fixed position in terms of the design itself. Now, I was pulling up that simulator in order to kind of show you where it is, and we could obviously change it from an iPhone 6 to an iPhone 4 or an iPad up here just by pulling this drop-down down. But one of the really cool new features that's in Xcode is a new assistant editor. If you click your assistant editor button down here and go to automatic, there's a new preview here. This is awesome. What it allows me to do is actually preview my design for various form factors all in one window. So this is the iPhone 4, and you can see my label's not in the right spot. It's clearly way off to the side. I can add in other designs here. So let's put in an iPhone 4.7 inch, an iPhone 5 inch, and maybe even an iPad, and I can see all of them at the same time. And so I can kind of see what happens when I move this label around to my various design on these different form factors. This is very, very handy because it means I don't have to sit there and launch the simulator each time I make a change to figure out, well, what does it look like now? Right? It gives me sort of a design preview because clearly the design surface isn't showing that to me. Right? It's just showing me physical frames, not where it's going to lay out on each device. You can also go to the bottom border here and click on this edge here to switch it from portrait to landscape. And so you can see what is it going to look like in landscape. There it actually kind of is centered, just not on the y coordinate, but at least x, it's almost centered there. All right, so what I'd like to do is I'd like to actually get this to center properly. So what do I have to do with that? Well, here's the deal. So as you saw, the designer really didn't do a lot for me, right? It just puts things at fixed points. And so when I say that I'd like to center something or wherever I'm going to place it, it's just fixed in space. And as I rotate or if I change the dimensions of that particular device, it doesn't move. Everything sort of just stays where it is. That's not adaptive. That's just plain old fixed design. We don't like that. So what do? Well, in iOS 6, Apple introduced auto layout. That, for some of you, may be a bad word or something that you don't want to hear about. How many of you have used auto layout? Okay, so about half the room. So auto layout was a replacement for something called springs and struts, or sometimes referred to as auto resizing masks. Auto resizing masks allowed me to basically take a view and position it relative to its super view. So I could say, for example, lock this to the left edge of the super view by 10 device units or something like that. And the system would always keep that in place. So as I rotated it, it would kind of shift that view around. It was the way we did sort of adaptive design prior to iOS 6. The problem with springs and struts was that it was a bit limited. You could only create relationships between a view and its super view. So sibling views could not have relationships. All right? And so the types of relationships that we could create were somewhat limited, which meant that we had to create code to compensate for anything that it was incapable of doing. And so you often had bits of code in there to handle orientation changes and things and to shift various elements around. And so in iOS 6, they introduced auto layout. It actually came from Mac OS. They had created it earlier than that. And what auto layout is, it's a much more flexible layout system designed around constraints. Constraints are simply linear equations. We're not going to do a whole lot of that here, so you can breathe a sigh of relief. But the idea is I can create formulas to decide exactly how things were going to lay out. The problem with auto layout is that with all that flexibility comes, what is the line? With great power comes great responsibility? No, no, no. With great flexibility comes great complexity, right? And so auto layout, I like to think of it as an API that only the people who created Objective-C could have designed, right? It is hideously hard to use, and anybody who sat down and tried to play with it has probably pounded their head against a wall a few times. In fact, Steve Wozniak, one of the co-founders of Apple, had a great quote, "Never trust a computer you can't throw out of a window." I think he had auto layout in mind because it makes you want to take your Mac and kind of toss it out. Those new 12-inch laptops are probably pretty easy to whip. If you've got a Mac Pro, you're probably out of luck. Those are a bit heavier. So auto layout's all about constraints. Constraints basically determine the position or the size of the element. And they're just mathematical formulas. So they essentially create the rules. As an example, we can say the left position of the view is equal to the superview's left position. Okay, so this says I would like the left coordinate of my view to be equal to whatever the left coordinate of my superview is. That's a fairly simple formula. I can also add in a constant. We can say the top of my view is equal to the superview top plus 20. So I'd like to be 20, I'm going to say pixels. I really mean device units. Okay, so pixels and device units aren't quite the same thing. But if I misuse the word, I apologize up front. I'm not a native English speaker. I'm from America, so you guys will have to forgive me. But we can add a constant in here. So we can say I'd like it to be positioned 20 device units from the top of the superview. I can also create relationships between views. And so this is something that Springs and Struts had problems with. But I can say that I'd like my view to be, the top of it to be 8 units from the bottom of some other view, okay, that's also in the view hierarchy. And then finally, I can put in actual ratios. Again, something Springs and Struts was incapable of performing. I can say I'd like my height to be half of the superview height. All right, so this is simply a ratio or a multiplier that's added to it. Now, I mentioned that these are simply linear equations, and the system's going to take all of these equations and solve them together. And really what the equation looks like is this. We have some attribute, A1, is equal to a multiplier times a second attribute, A2, plus some constant. Okay, so this is a constraint in mathematical form. The system takes all of these constraints, creates a big linear equation, solves that equation in order to figure out exactly where things are supposed to go on the screen. Now, what that means is there has to be a solution to that equation. What they call this is it has to be an unambiguous layout. In other words, when I go through and I run the math on it, I can't come up with multiple answers. I've got to have one answer to the equation. So when we have competing constraints that cause us to get different answers for some value, the system's not going to like it. And invariably, the best you can hope for is that your layout just doesn't work the way you expect it to. The worst is your app will crash, where the layout system just says, oh, sorry, I can't do what you're asking. I'm going to throw an exception. We've got a runtime issue, and we're not going to work. So constraints actually are quite interesting. Constraints essentially create the rules, and they are applied to views. So anytime you create a constraint, you're always creating some sort of rule from one view to another view. Okay? It's always done to attributes of that view. Attributes being left, top, right, bottom, sometimes called, by the way, leading and trailing. You'll see that word used a lot. Leading can be either the left or the right based upon the direction of the language. So leading typically in an English-based language would be from the left-hand side, so it'd be the same as the left. But if I picked a right-to-left oriented language, it would actually be the right-hand side. We also have other attributes such as width and height, or baseline, or center X or center Y. Okay, so those are attributes of views. We apply them between views. It can be to itself as well. So I can apply a constraint on a view where the other view is itself. So I can say, for example, the width and height are always equal. Right? Basically, the aspect ratio will always be kept in sync. So as the width changes, it will change the height as well. When we create constraints, they're always cumulative. This is an area that people get into trouble with. One of the reasons why auto layout has such a bad rep is because as people begin to use it, they'll begin to kind of create constraints, and invariably they'll end up in a condition where we end up with an ambiguous layout, and then it starts putting things where you don't expect them to be. right? Your fields will be in the wrong spots on the screen, and you'll scratch your head and wonder what happened. Well, part of the reason why that happens is because constraints never overrule each other. When I apply a constraint to a view, it takes all the other constraints that are applied to that view into consideration as well. So they're always cumulative. They're always added to the equation. They never cancel each other out. If I have two competing constraints, that's an error. That's not something that the system can solve. Okay? Now, that said, constraints do have priorities associated with them. So I can say, for example, that if we do have a conflict, I expect that that could happen. Let me give you an example. Say, for instance, that I say that I would like the width for a particular label to be greater than or equal to some value. Say maybe it's 50. And I also say that I would like the horizontal distance for that label to its sibling, which is a button, to be at least 10. Well, it's possible that as I begin to rotate the device, if it's a fairly constrained device, that I could run into a case where one of those constraints can't be met. Either the width, there's not enough width to satisfy it and still keep a 10 device unit boundary from its sibling. Okay? When that happens, one of the things I can do is I can set priorities on the constraints to say that this constraint is more important than that one. And what that will do is when it goes to solve that equation, if it runs into an ambiguity between two constraints, it'll look at the priority. And if one of them is lower, it'll throw that one out and just use the higher priority one. And so by using priorities, we can sort of create rules where we understand that it's possible where these rules can't be satisfied, and we can decide which ones are going to break the condition. Okay? We can also cross views. This is actually quite interesting, and it's something that most people don't really take full advantage of. The idea is this. Not only can I create constraints between a view and superview, which is very common, so a view and its container, or the owner of that view, but I can create constraints between two sibling views. But I can actually reach outside the view hierarchy. So for instance, I can take and create a constraint between a view that's contained inside some subview and the parent of that original subview. So I can actually go across the view hierarchy. Now there's two areas where this does not work. One is, or at least rules I should say, one is the views must have a common ancestor. So somewhere in the visual tree going up, there has to be somebody that they share. Okay, so I can't, for example, create a constraint between a view that's in one view controller and a view that's in another view controller. We can't do that. I mean, that just makes sense. Those are two different screens. We're not going to create constraints between them. The second place where this doesn't work is if the view happens to be inside of a scroll view. So if I have a UI scroll view in my display, and I try to create a constraint, I can't go outside the scroll view. And again, if you think about it, this makes sense. The scroll view is adjusting the viewport. So it's essentially sliding that view up and down and applying transforms in order to move it. And so it would be very difficult for the system to manage a constraint where I said, hey, you know, for this view that's inside the scroll view, try to keep 10 pixels or 10 device units distance from something that's outside the scroll view. Because the position's being moved fluidly as a result of the scroll view. It might not even be on the screen, right, as I begin scrolling the content. So scroll views kind of break the constraint system. You can't put constraints outside of the scroll view. But other than that, generally speaking, the rules will apply, and we can create some very nice rules to be able to do this. So let me show you auto layout. Now, again, this is something that's been around for quite a while, but I want to show it to you because it's critical to adaptive design. You have to be able to understand auto layout in order to make this work. So let's just take our label as an example here. So recall that we wanted this to be in the center. Let me close the document outline again to give myself just a little bit more room. It's a little constraining on this monitor. And so here's how we can create constraints. We have 3 different ways to do it, and I'm going to show you all 3. The first way we can do it, and probably the easiest way, and so if you're just now starting with constraints and auto layout, this is the way I would use, is this little menu bar down here. So notice we have 4 little buttons down here. The first is for alignment constraints. Alignment constraints are where we're trying to line 2 views together. And so if you click this little alignment button, you'll see we can create alignment constraints on the leading edge, that being the left or right, the trailing edge, again the left or right, the top edge or the bottom edge. Now notice all of these are disabled. That's because in order to create most alignment constraints, you have to have 2 views. So I have to have 2 different views selected for it to do the alignment. It doesn't make sense to try to align to myself, right? I can also create horizontal center, vertical center, and baseline constraints. This being, I would like to put these two together horizontally or vertically, or I would like to put their baseline. For instance, labels for text, I can put the baseline together. And then the two constraints that actually are enabled in this case are horizontal center in container and vertical center in container. Now, this is actually what I want, and so I'm going to select just one of these, and then I can get this add one constraint. And I'm going to click the button. Now, notice what's happened here. This is quite interesting. The minute I add a constraint, now the system recognizes that I'm taking control of the frame layout. Okay, so now there's rules applied to this. There were actually rules applied already. So they call them prototype constraints. If you don't set a constraint on something, there really are constraints. It's just a constraint to put it at that frame position. That's what happens when you run it. In this case, I've got a constraint applied, which is a rule to center this particular label. And notice that it's in orange, and I have this line. This line is showing me that it's a horizontal center. Okay? So I'm horizontally centering the label in the center of the screen itself, or in its super view. And notice that there's a little dotted rectangle way at the top there. Well, what this is showing me is this little orange line says that this is an ambiguous layout. And what it means is there aren't enough rules on this label to be able to position it accurately. And really what it's saying is, if you notice that little dotted line, that's actually where the label's going to go. And if we actually look down here in our preview, right, this is where the preview gets really nice. Let me just double click to kind of zoom in. You can see the label is actually positioned at the top of every single one of those views. Well, why is that? Well, the reason why is because we told it to center on the x-axis, but we didn't tell it anything on the y. And so it put it at coordinate 0, which is at the very top of the view. This will run, even though it's ambiguous. The system will simply place the label at the top, and I'll get some sort of warning potentially spit out in my debug. So it's not a conflict. It's just we're missing the rule necessary in order to correctly place this label. Okay? So we need to add a y constraint to this in order to properly position the label itself. So we have, again, we could go here to the alignment menu, and we could do this by simply clicking the alignment menu and then using the vertical center in container. Alternatively, here's another way we can do it. If you go to the editor menu, notice we have an align menu up here as well. You have to select something. But we can go to editor, align, and you can see we get the same sorts of things here, including some keyboard shortcuts. So as you start to get used to this and you begin doing stuff, if you want to memorize keyboard shortcuts, you can. And of course, Xcode allows you to assign keystrokes to different things as well. And so I can say vertically center in container through the editor menu. Now notice that as soon as I did that, we get a second line on this. And so you can see that now I have both a horizontal and a vertical line kind of crisscrossing on that label. But more importantly, it's blue. It's not in orange anymore. That means that this is an unambiguous layout. This label is fully defined. It knows exactly where it's going to be placed. Now here's an interesting thing about this. Notice that the only two constraints I put on this were a x and a y. I told it where I want it to be positioned. All right? But really, anytime that you deal with auto layout, normally you have 4 constraints that you need at a minimum. We need an x position, a y position, a width, and a height. But we didn't set a width and height constraint on this label. And the reason why is because the label knows how big it is. Okay, so some controls in iOS have what they call an intrinsic content size, meaning they know how big they are based upon the content that's applied to them. In this case, the word label is the content size, and therefore it knows exactly how big the label is going to be based upon that size. Now, let's just run this one more time in iPhone 6 just to make sure it actually does work and that our preview isn't lying to us. So you can see here is my 138 by 323. That's different than the original frame was. And notice when I change the orientation and move to a landscape, it moves to 284, 177. That's the constraint system applying that. It moved the label when I changed the orientation, okay, because now I had more horizontal space available than vertical, and I had to shift the label as I did it. Okay? Now let's try something a little more complex. I'm going to delete this label. And let's put in here a label at the top. So I'm going to stick a label here. We're going to call this name. And then let's put in here a text field. So I'm going to grab a text field, throw it in right there, and let's just stretch it out all the way across. Now, I'm going to take these two and I'm going to hold the Option key while I have both selected and drag. That creates a copy. All right, and notice it gives me nice little guidelines. And we'll just create 3 of them. And we'll create one that says it's a phone and one that says it's email. Now, again, remember, we haven't put any constraints on this. And so if I look at my preview down here, you can see that it's kind of correct, except notice that here on the iPhone 4, my text fields just run off the edge. Right? They're too big to even display in that. Here on the iPhone 5, it's the same way. On the iPad up here, they actually end about halfway or just a little over halfway. Okay? Again, because the system just laid it out. It has a frame. It knows how big it is. Boom, it's done. It's not going to move or reposition in any way. So we need to put constraints on this in order to make this work properly. Okay? So I told you that we can use the menu bar down here. This is the alignment constraints. The second menu is called pin constraints. Pin constraints allow me to create relationships between, again, typically 2 views. But what I can do is I can actually put constant values on it. And so here I can say this is a left or leading constraint, top, right, or trailing constraint, and bottom, and I can put an actual constant value in there to say I want it to be 10 pixels or 16 pixels or whatever it happens to be. I can also do the same thing through the editor menu up here. And so if I select something, we can go to the editor menu and go to pin, and again, I get the same values here. But the third way, and the way that I tend to use constraints, is you can actually click on a view, hold the control key, kind of like you're creating an action or an outlet, and drag to another view. All right, so if I drag horizontally to the left, I get a little pop-up when I release the mouse, where I can create a leading space to container, a center vertically in container, equal widths, equal height, or aspect ratio. So I've told it the 2 views, the view I started the drag on, the view I ended the drag on. I'm going to create a leading space to container margin. And so that's now created a constraint, and notice I get my little orange rectangle here saying, oh, now you've got a rule in there. I've got to have both the x and the y. I only gave it the x. I didn't give it y, so it's at the top. So I'm going to hold the control key again and drag up this time. And notice I get now completely different options. Top space to layout guide, center horizontally, and again, equal width, equal height, and aspect ratio. And we'll create a top space to top layout guide. That's now blue, and so everything's okay with this. If you're interested in seeing the constraints that have been created, you can click on the view itself and go to the layout section in properties. And you can see that we have a section here on constraints. And so this big section here allows me to select the constraints by clicking on the lines. And then below it, it actually shows me both the constraints. And so I have a leading space to super view, and I have a top space to top layout guide. And so you can hit the edit button here to be able to adjust the constant, or you can even double click on it to be able to adjust everything about it. So here you can see the first item is name leading is equal to super view leading margin. The constant is 0, so it's going to be right at the margin itself. So in iOS 8, the system enforces margins. I think they're like 16 device units, or it's either 8 or 16, I can't recall. So it's a system-provided value. And by default, most of the time when you create constraints, it's always going to use those margins. And so this 0 really isn't 0. You can see it's actually up against this margin line here. Okay? We have a priority, and then we have the multiplier to be able to adjust this. All right, so I've created one for this, and now let's create one for the text field. And so I'm going to, again, create a top constraint. So I want it to sit from the top. And I'd like it to be to the edge on the right-hand side. So I want a trailing space to container margin. And I'm going to create one onto the name itself, which is a horizontal space. Now, notice when I click on this, again, everything's good. I've created 3 constraints on here: leading space, trailing space, and then a top to layout, because, again, this has an intrinsic height, at least for the text field. So the text field knows the height, it doesn't know the width. Okay? So those 3 are enough to create an unambiguous layout for this. All right, now, if you look here, now you can see that my name is properly stretched out on the iPad view. It's properly stretched out on the iPhone 5 or 6. I think this was actually 6. And then it's properly stretched out on the 4 or 5 and then the 4. Okay, so it's moving as it goes between them, but not for any of the others. The others, we don't have any on here. So I'd like to do the same constraints for these as well. I'm going to select both of these together by just holding the shift and selecting both, and go to my pin menu here. And now I can just click the little margin constraint area here. I'm going to leave it on margins and say 0. That'll create a left constraint for me. I can also create one on the top. That'll create one up to the top, and then I can add all 4 of those constraints. Now, interestingly enough, notice that this one is in orange now, which means that there's a problem with this particular item. And so you can see that we have a leading space to superview. That's fine. And then I have a top space to iPhone equals 17. So why is it in orange? Well, one of the ways that we can kind of diagnose constraint issues when you see them in the designer is you might notice over here on the view controller scene, this is the document outline. If you don't see the document outline, you can go to, I think it's under, I thought it was view, but I don't see it there. There is a, here it is. It's under editor. So there's a hide document outline. When it's hidden, though, it'll say show document outline. So if you don't see the document outline, you should go ahead and display it. It is incredibly useful when you're dealing with storyboards because it shows you the whole view. But one of the things it gives me is the actual warnings and errors themselves. This is in orange, meaning that it's just a warning. The system would run. And if you click on this, it'll actually tell you the problem. And so notice it says the expected is Y95, height 20. The actual is Y96, height is 21. And so what it's basically saying is the frame is wrong. We're in the wrong position. So when this happens, you can click the little triangle here and say, let's go ahead and update the frame. So it has some resolutions here. We can either update the frame, update the constraints to match the current frame, reset to the suggested constraints, and then I can also check the little box saying do it for every view inside the container itself. You can get to this same menu down here. So this third little button, it kind of looks like a Darth Vader TIE fighter down here. If you click that, it'll give you that same menu. And so if I select something here, like this email, click this little button, I can say update the frame from this menu. And notice as soon as I do, it shifts, my constraint error goes away, and all is good with this particular display. Okay, so we've successfully kind of built this. So let's put in the other two. I'm going to put one vertical spacing on that one, vertical spacing on that one, and then let's go ahead and select both of those and put it over to the right. So I'm going to put a margin on that side and a margin on that side. Let's add the constraints. Okay, so now everything looks good in terms of my view. If I look down here, I can see that all of these are actually looking pretty decent. Everything is stretching out just fine. Now, one issue that I have with this view right now, if I were to run it, you would see that it all looks good. Even if I change the orientation, it's all going to be okay. So if we take the iPhone 4-inch and we say go to landscape, you can see that it is stretching out to the edge. Okay, so my text fields are properly moving and reorganizing themselves. The only thing that we might have an issue with here is, let's just put in a little piece of code. So I'm going to go ahead and let me do this. I'm going to open up my assistant view, but switch from the preview back to the view controller. So this again is Swift, and I'm going to take, say, this phone, and I'm just going to create an outlet here. We'll call it phone label. Okay, and then I'm going to go ahead and put a button in here. So let's just throw this button down here. Change label is what we'll call it. Let's create a constraint. And what I'm going to do is go ahead and let's actually use an alignment constraint. Let's horizontally center it in the container. Let's update the frame when we do that. And then let's go ahead and, again, position it back down. So notice it moved as soon as I did that. So I'm going to stick it here, hold the control key, and drag it up to the text field and say let's put a vertical spacing on it. So that'll keep it locked in place there. Let's go ahead and create an action for this. And so I'm going to call this onChangeLabel. Make this an action. Say connect. Oh, I put it in the wrong spot. Let's try that again. There we go. Action. onChangeLabel. Okay. So in my action, let's just say if phone label .text.utf16 count is greater than, let's see, phone P12345 is greater than 6, then let's say phone label text is equal to phone. Else phone label text is equal to the phone number. Okay? And let me run this. All right? So you can see everything's lining up properly, but I click the change label, and notice what happens. My label changes, and because of the constraint that we created here that said that we want there to be some specific space between the label and the field gets moved over. Okay? That's actually not a bad thing that happened, right? It didn't overlay the text field, so it sort of did the right thing, but ideally, what would I want to have happen in this display? Does this look right to you? What would I like to have happen here? What do you guys think? Yeah, I'd like to move everything over, right? If one of them is over, I'd like them to line up. There's nothing worse than a UI design where you've got things that don't line up, right? It sort of tells your users that you didn't pay attention to the layout, right? That you didn't kind of pay attention to the details. So if you didn't pay attention to the UI design, what's my assurance that you did the attention to the code, right? So I'd like them all to kind of line up. So let's do that. So how can we do that? Well, there's another kind of constraint that we can put on here. If I select all three of these, notice that I can use the alignment menu here, and I can say align on the leading edge. All right, the same thing would apply if I aligned on the left. So we could do this as well. I could click one, drag to a second one, and say align on the left-hand side. So this works as well. And then one onto this one and say align on the left-hand side. So now all of these align. If I run this now, or even just change the label here, the phone number, notice that now they all three change. Okay? Those are not conflicting constraints. The system, when it goes and figures it out, says, okay, we're locked on the right-hand side to the super view, we're locked on the left-hand side to the label, and they're all the same width. We're good. Okay? So those are not in conflict. It is actually an achievable equation from that perspective. All right. So you can see kind of how the constraint system works here, just in the sense of being able to kind of manage that. Now, there's one other thing I want to show you here. So I'm going to create actually another view controller. So let's see. Drag this up here, drop it. And actually, let me close the assistant menu here just to give us a little more space to work with while we play with this view controller. So there's a couple things I'm going to do. I've got some assets here that I created that I'm just going to go ahead and put into my app. So let me open the document outline. I'm going to go into my image assets. If you're not using asset catalogs today, you should be. These actually are quite a bit more versatile than just placing images in there. So let's create one called background. Let's create a second one called, let's call it current location. We'll call it current location marker. All right, and I'm going to go over to my assets here. And current location marker, let's just say 1x is this, 2x is this, 3x is this. So the 1x, 2x, 3x, these are used on different form factors. 1x is the original iPhone, 2x would be a Retina display, 3x is iPhone 6 Plus, okay, with its higher scaling. If we go to the background, let's take this one and drag it up here. All right, now I've got some images to play with. I'm going to go ahead and put an image view in here. So let's say image view. There we go. Drag that in here. And what I'd like to do is I'd like to actually position this so that it's locked on the left, top, and right, but I only want it to take up half the height. In other words, I want it to be half the height of the actual view itself. So we can obviously lock it on the left, right, and top. That's just the pinning menu. So I'm going to come here and I'm going to say lock it to 0. Now notice that the values that are here are -16 on the right and left. That's because, if you look at this, I'm all the way to the edge of the super view here. And remember I told you that iOS 8 likes to put margins in there. That's a 16 device unit margin. And the reason it's giving me this is because of this checkbox, constrained margins. And so if I uncheck that box, so if I take this and select it and then come up here and I uncheck this box, notice that they now change to 0 because now it's relative to the super view, not to the margins. Okay, so I'm going to pick the top, left, and right and say add 3 constraints. Then what I want to do is I want to create a constraint between the image view and its super view for the height. Now, it's really difficult to do that through the pinning menu down here. And it's really difficult to do that with control drag because I don't have any surface here to get to. Right? I would have to kind of move this up a little bit to be able to drag out to the main view. This is where the document outline can be really helpful because I can come over here and control drag from one to the other. You can also drag from the design surface over to the document outline. So both of those approaches work. And what I'm going to do is I'm going to create an equal height constraint here. And then we're going to take that equal height constraint and edit it and say, right now it says the first item is the super view height is equal to the image view height. And so they'll basically be kept in sync. But what I really want is I want the image view height to be half of the super view height. And so in this particular case, it created the relationship in the wrong direction. Right? Typically, the one that's on the left, the very first item, is the one being assigned, the attribute that's actually going to get a value. And what I really want is the image view to be that. And so if you click on this, you can reverse these two values. Just remember the first item is the one being changed. Okay? And so I want the image view height to be equal to the super view height times 0.5. Now, when you put in decimals like this, always put a 0 in front of it. Watch what happens if I just say 0.5. It goes back to 1, and you'll scratch your head and go, well, I thought you could put decimals in here. Why won't it let me do that? Well, you need a 0 in front of it. And as soon as you do that, notice that now my UI view is actually in the top half of the view. So let's go back to the properties of this and actually just change this to be the background. And let's go ahead and make it an aspect fill so that it actually has our image here. So this is the Sherlock Holmes Museum. I'm also going to put in here a map view. So let's drag that in. And this one, I'd actually like to, again, pin it to the left, right. And so I'm actually going to change these values. Let's get rid of the margin again. So let's make that 0, that 0, that 0. And then add those three constraints. And we can also tell it to go ahead and update the frame when we do it. Now notice that what just happened is now it's got a problem. And the image view just disappeared. And I go, whoa, what happened? This is fairly common. The problem is that I didn't add enough constraints in there to truly give it all four values. Where is it positioned, x and y, what's its width and height? What did I miss? Right? We put it on the left, we put it on the right, we put it on the top. We missed the bottom. I'm sorry, we put it on the left, right, and bottom. We missed the top. Or did we miss the top? We missed one of them. And we can go over here and we can see which one it is here. It says we need a constraint for the height. It doesn't know how big it's supposed to be, which is why it's now 0. I'm going to go look at these constraints. I might have actually done it to, oh, I did, top space. I didn't do the bottom. So let's go ahead and drag it to the view, and let's create a bottom space to bottom layout guide. And notice it still didn't change the height, because what happens here is Xcode says, well, it was already at 0, so when I create this constraint here, and you can just click the constraint to edit it, it's set the constant to be 300. So there's always 300 device units, which means that there's no map view. And so whenever you do it this way, and it wasn't in the proper position, you're always going to want to go change that value. This is why auto layout was so frustrating to people, because Xcode just does some silly things. It doesn't do things the way you might expect it to. And so notice now I get my map view. And if we look at our preview, you can see that the system has it actually in the right space, right? And let me just make this my main one. You can see that it's actually in the right spot, even in all of the different orientations. So let's put a couple more things in here. I would like to put a label in here as well to just say what this is. And so let's insert a label. So I'm going to drag a label in here, except, and I'm going to make this label white. I meant to just pull it down, but that's okay. We can do it through this too. Make it white. There you go, it's white. And let's change the font size. So I'd like to make this custom Helvetica. Let's make it, say, 24. So it's nice and big. Okay. Now, I'd also like to put some other stuff on this, like a button to be next to this. And so this is going to be the Sherlock Holmes Museum. And I'd like a button to be on here. And we could totally put constraints on this to be able to manage that and just put the label here and the button over here. But what I actually like to do is kind of subdivide my UI so that I have different sections to work with. And so I'm going to take and go to the editor menu and say, embed this view, this label, in another view. And so now this is actually inside of another view, and I'm going to make that view black. Just pick this color here. And in fact, let's also come down here and just change the opacity so it's half black, so 50%. And then let's kind of create some constraints for this. So I'm going to position it where I think it should be, kind of like this. There we go. And then let's go ahead and put our constraints on this. So on the view itself, I'm going to go ahead and create constraints for the, oops, not for that. Let's delete that one. Take the view and let's actually rename it as well, because that way we can kind of see it better. If you long click on it, we can call it container view. And then I can drag up to the view here. Now notice it's got leading space to container margin. Again, it's trying to enforce margins, but if you hold the option key down, notice it changes the values here to be leading space to container. I can then use shift to be able to select multiples. Okay, so now I can create on the leading and trailing space. And then let's go ahead and lock it to the bottom of the background. So I'm going to put it on the bottom. Now this bottom constraint here, if we go look at it, align bottom to background, let's just make sure it's right. So background bottom is equal to container view bottom. Let's actually just, I like to have them reversed. So it's really container view bottom is equal to background bottom. That's what I like to see there. And you can see that it looks like it's okay. And so then what I want to do is I want to take this view. So this is the label that's inside that container view. And let's go ahead and center it horizontally and vertically within the container. All right, and let's update our constraints for that. Okay, so now this got centered, but notice that it doesn't really look centered to me. If we go look at the constraints here, you can see why. It's got an align X to 65.5. Again, it just kept it where it was. And so what I'm going to want to do there is edit this constraint and change this to be 0 so that it shifts to the center. Does that make sense? Then let's put a button in here. And so I'm just going to stick a button over here in the corner. And for this button, let's change it to be a info light, and let's put on here a tint of white. Okay, so there we go. So now I've got this nice button here. We'll center this as well. So let's put this centered vertically in the container. And then let's put a trailing edge on it. And notice that that's okay because the button knows its width and height. So let's look and see what this looks like. So if we go look at our previews, you can see this looks pretty good, except it's kind of large. This piece right here is a bit large, the container view. Let's look at the constraints that got applied to this. So we have a trailing space to superview, leading space to superview. We've got a ratio that got added here somehow. I'm going to delete that. I'm not even sure what that is. We got an aspect ratio added to it. Now notice when I did that, this is now red. So it indicates that there's a problem. And in fact, if I click on it, you can see that there is some kind of issue. And if I look down here at the actual design, the view is completely gone. Like it's not there at all. Like it's completely missing out of this. Again, if we click on this little error, it says the container view needs a constraint for the Y position. The problem is this. The label knows how big it is. The button knows how big it is, but the view has no intrinsic height to it. Like it doesn't automatically look at its children and say, how big are they? Let's make myself that big. The view's intrinsic height is 0. And so by default, its height is going to be 0 in this case. But I don't really want it to be 0. What I want it to be is big enough to fit that label and that button. It turns out the label's the bigger of the two. So I'm going to create a constraint between the label and the container itself. And I'm going to say that I would like them to be equal height. Okay, so I want a height constraint to be created for that. If I go to this container view and pick that equal height constraint, then what I can say is that, and let's reverse it. So container view height is equal to Sherlock label height, but I'm going to add in a constant of 20. So I'd like it to be 20 device units bigger than that. Let's update our frames and see what happened. So update frames, and now that looks better. Right, so you can see that we can kind of create some of these things in order to realistically build the types of UI that we're trying to build. All right, so that's auto layout. It is complicated, But if you play with it, you can use some of the hints that the designer gives you in order to kind of figure out what's wrong with your layout as you go through it. And look at the constraints and see exactly where, what's actually being positioned there.
Sorry, excuse me.
Yeah, go ahead.
You said that the intrinsic, the default value for a view is 0.
Yes.
But when you actually added that half black background, you actually dried.
I did, yes.
So I would have expected to actually get that value as a...
Yes, and so when you originally add the view on there, then what happens is because we have no constraints that we've applied, the system just uses whatever frame we drag out. So it's fixed in position and fixed in size. And so there is a constraint being applied, it's just based on where it is and how big I dragged it out. But the minute I put one constraint on it, it throws that away. And now I have to define the full definition. I have to give it position and width and height. And so I have to do both. All right, so we've seen auto layout. And that is really the cornerstone of adaptive layout in iOS. But there's one other piece that iOS 8 kind of brings to the picture. Everything that we just did, you could do in iOS 6 and 7. Right? So there's nothing new in what I just did. So we're going to apply this to actual different devices. And the idea is that we're going to use another construct that iOS added in the system called size classes. Size classes allow us to abstract away the device form factor of iPhone 4 versus iPhone 5 versus 6 versus iPad for different variations. And we have two different size classes in the system. We have the regular size class that describes a dimension, either width or height, that has available space. In other words, it's either got a reasonable amount of space to display content, or it's got some sort of scrolling surface that allows us to adjust that space. So a scroll view or something like that. The second one that we have is the compact size class. The compact size class indicates a dimension where we're constrained in space. We don't have a lot of area to be able to display content in. We're going to apply these size classes to both the width and the height. So in other words, for the width and the height, it will have one of these two size class definitions. These are the two that Apple has defined up to this point. They may define future ones as well for, say, a watch. Maybe there's an ultra compact or something like that. When the watch actually hits and we can build apps on the watch. Today, the watch itself, the Apple Watch, if you guys aren't familiar with sort of the programming model, it doesn't actually run iOS, it runs WatchKit, which is just a component, and it's really the phone that's pushing the content to the watch. And so it's not really an app running on the watch at all, it's kind of like a second display of the phone. And so each dimension, width and height, is going to get one of these size classes assigned to it, either the regular or the compact. And what Apple has done is they've defined, for all of their devices today, a specific size class for each dimension so that we no longer have to say, is this an iPad in the landscape orientation? Instead, we program two size classes. Our UIs are going to be designed to size classes, and then the system will then adjust the shape of the UI based upon the orientation and the device it's running on. So just as a breakdown here, you can see that in the width dimension, if the size class is regular and the height dimension of the size class is regular, we know that's an iPad in either portrait or landscape. It has lots of space in both dimensions. If the width is compact, but the height is regular, then they consider that to be any one of the iPhones in portrait orientation. So that's any iPhone, okay? If the width is compact and the height is compact, then that's either an iPhone 4 or an iPhone 5 in landscape. So they're both compact. And then if the width is regular, but the height is compact, then that's an iPhone 6 Plus in landscape. So this is the definition that they've created up to this point. We program against the size classes. And so we're not going to say, hey, I'm looking for an iPad in this dimension. Instead, we're just going to program our screens to be compact width and regular height or something like that. Now, when we actually build out the designs, there's one other value that comes into play. This is a designer value. Okay, so regular and compact are the two concrete values that you can assign to a dimension, but we also have an any size. Any size is kind of a catch-all. It's a wild card. We use it in the design surface, and when we lay our design out, if we place something in the any width but regular height, then it will apply to anything on that row. So, as an example, if I say that I would like it to be compact width, any height, then it applies to any iPhone in portrait or the iPhone 4, iPhone 5 in landscape. So both of these devices would be hit by this one design. Okay? This is how we're going to create more genericized UI layouts. In the same way, if I said, I want to target any width, but only compact height, I would only use that layout for iPhone 6 Plus in landscape, or iPhone 4 or 5, in 4, 5, or 6, actually, in landscape. All right? So these two would be used in that case. It wouldn't be used for an iPad, and it wouldn't be used if we were in the portrait orientation. All right? So this is sort of the system that's going to work here. So let me show you the size class implementation inside of Xcode. So I'm going to go back to Xcode here, and let's just create one other view controller. All right, so I'm going to drag another view controller up here. Let's go ahead and close out this. All right, and what I'm going to do is, let's just put a label in here. All right, and we'll center it here, and we'll say this is, we'll call this any. All right, and I'm going to go ahead and center it vertically and horizontally, so I'll just create alignment constraint for horizontal and vertical centers. Add 2 constraints. That's now going to be centered on every device. Now, we're in what's called any mode, and you might have noticed down here at the very bottom of the screen, there's a little any here. This is the width and height size class. If you click this, you'll get a little pop-up that's not very intuitive until you start playing with it a little bit. And what it allows you to do is define your constraints based on size class definition. So just as an example, if we come up here and we say, I would like, I want portrait actually. So let's use for all compact width layouts, 3.5-inch, 4-inch, and 4.7-inch iPhones in portrait or landscape. And I'm going to click that. 2 things have just happened. Notice first that my design surface just changed to an iPhone sort of looking display. The second thing is the little bar down here at the bottom turned blue. Okay? It indicates that I'm not in the generic any size. In other words, changes that I make to the view at this point will only be applied to this size class. So as an example, if I drag a second label in here and I say this is compact any, and I'm going to go ahead and horizontally align this. And by the way, here's another way to do horizontal alignment. You can click and drag to the side. And so notice I get, if I do a diagonal drag, it doesn't know what direction I'm going, so it gives me all my choices here. And so I can say center horizontally in container. And then I can create a relationship between those two that's vertical spacing. So notice that I have my pieces here. If I go to my preview and go look at what this looks like, so here we are in iPhone 4-inch. I get any, and compact any. Here we are in 4.7-inch, any, compact any. Here we are in 5.5-inch, any, compact any. Here we are in iPad. No label. So that change of adding that label into the design only impacted the iPhone displays in either portrait or landscape, right? And in fact, if we put the iPhone 6 into landscape orientation, remember that doesn't fall. That's actually a regular width, not compact. You can see that we lose the label. And so as I rotate the device, the label itself goes away. It's only applied to this specific size class. And so I can manipulate things based on these size classes. Now when I'm done, I can go back to base values for all layouts. And you can see as soon as I did that, we lose that second label. It's no longer here. But if you look inside your view, so if I collapse this one, and just look at this, you can see there is a label up there, but it's grayed out. All right, so I can sort of see it, but it's not available in this size class, and therefore it's grayed out in the document outline and it doesn't show up in the designer. All right, so that's size classes. Now, let me just show you some of the things that we can do with this. So generally speaking, what you're going to want to do is you're going to want to design the majority of your layout in that any mode, so that first view that you come up with. All right, that's your generic view. That's the one that applies to every single device, no matter which orientation it's in. So try to do the majority of your actual work in the base layout. That's what they call it, the base layout. Then you begin applying specific conditions based upon the type of device or the orientation that's there by switching to that known size class and work from the most generic to the most specific. And so, try to stay on an any on either the height or width, and only drop to the most specific if you absolutely need to make a change for that particular form factor or orientation. And we can do this in code as well. So clearly I'm doing all this in the designer. In the code, what Apple has actually exposed to you is something called a trait class. And it includes the size class. So the trait class is actually a collection of values that includes the horizontal size class. Remember, that is any, regular, or compact. The vertical size class, any, regular, or compact. And then also the UI idiom, that's iPhone versus iPad, and the display scale. So is it a Retina display? Is it an iPhone 6 Plus display? What is it? These two values here never change throughout the life of the application, so they're fixed in time. These values change at runtime. And as the values change at runtime, the system applies the constraints that you set up in the layout on that particular size class. That's how we're going to get our adaptive design. So when it takes all of these into consideration, it takes this trait class, looks at all those values, and that determines what size is that element, where is it going to be positioned, is it visible in the display, and even what image is available. So there's several little things that we can tweak in the UI design to reflect the size class changes. Okay? Now you might be wondering, where does this come from? Well, it turns out that one of the things that they did in iOS 8 is sort of push this trait system throughout the UI layer. And in fact, what happens is the system creates what they call a trait environment. That trait environment starts at the screen where it adds to the trait environment where some things potentially are missing. So the screen may not know, for example, what the size classes are. But it knows that it's an iPad and that it's a Retina display, because again, those are fixed device things. Then it reflects up into the window, into the view controller, and finally into all the views. And all of these layers get an opportunity to interact with that trait environment and influence it. Okay, and so we can use the trait environment to be able to do programmatic things in layout, or potentially show and hide things or move things around if we needed to do it in code. So you can still totally do all of that. You'll just use a trait environment, not the direct rotational APIs and things like that. So if you were using like the will rotate sort of APIs, those are deprecated in iOS 8. You don't use those anymore. Instead, you're going to use trait environments. And that's what's actually going to tell you that the system is rotating. In terms of the orientation itself, you're still going to use the UI device orientation. So that property is still perfectly valid. Now, the cool thing you can do with trait environments is you can obviously see them as they change, but you can also influence them, meaning that you can say, for example, if this is an iPhone 6 Plus, and I'm in the landscape orientation, I would actually like to have a different size class for this view controller. So I can force things to change based upon programmatic conditions. Here's an example of that. The UI split view controller was changed dramatically in iOS 8 and made available to the iPhone, so that now we can use a split view controller even in the iPhone, but it acts more like a navigation controller, so that when I display the details view, if you're on an iPhone, it pushes the view onto the screen. So it looks like it's a navigation push, not a split view controller. The advantage is I use exactly the same code for an iPhone versus an iPad, but on an iPad I get a true split view controller. On an iPhone I get a navigation controller, and it just works. So it's adaptive in terms of the API itself. We can actually change the split view controller's behavior on an iPhone 6, which has more space, to say, hey, if you rotate it into the landscape, pretend it's an iPad, and actually make it a split view controller where I have a master and a detail that's present on the same screen. Question?
As the trait environment essentially changes,
Yes.
and you use the apps, can you supply transitions between?
You absolutely can, yeah. So you have the ability to animate those. So you can obviously use the animation API with a closure to be able to push one thing from one place to another. You can also influence the change as the system itself is changing layout in response to the traits. There is you'll see it, I'll show it to you. There is actually an animation by default, but you can influence that animation if you choose. So yeah, you can influence this in a variety of ways from the API itself, and the system actually does some of this as well. For example, if you look at the navigation controller, by default you get a nav bar at the top with your back button and a title. In the portrait view, the nav bar is actually quite large. It's a larger bar, but when you switch it to landscape view in iOS 8, you might notice that it shrinks. It becomes compact. Okay, that's because the height size class went to compact, and so the navigation controller responded by actually shrinking the bar to make it smaller, to give us a little more space for content. that was actually put into the Appearance Proxy API. So the Appearance Proxy API is something they added in iOS 7 to allow us to kind of influence the way controls look visually. Now there are APIs in the Appearance Proxy API to be able to say, give me the Appearance Proxy for this trait environment. So when it's in the compact, regular, with this idiom and this retina display value, or this display scale. And we then get back a proxy that we can then do something with. So all of those APIs now actually take these trait environments to do it. So what can we do in the size classes themselves? Well, we can add or remove constraints. So I can actually disable a constraint for a particular size class and replace it with a different one. I can move things around as a result. I can also alter the constant of a constraint. Now, let me be clear on this. What I'm saying is, remember there's a constant value that can be added to a constraint. It's that C in the mathematical formula. That one piece is variable on the constraint. You cannot change the multiplier, and you can't change the source or the target. So the two attributes are not, they're immutable once the constraint has been generated. If you try to change those, the best you could hope for is probably a just not working at all. The worst is it'll probably crash. Okay, so don't touch any of the other values. But constants can be changed. And so I can say, when I move to, say, a compact size, I can adjust the constant to pull it a little closer to the left, as an example. We can also add or remove views. So I showed you this. I can actually add in a new view into the UI based upon a particular size class, or I can take one out. I can also alter the font size. So I may want to shrink a font or make it slightly larger based upon how much space is available in one direction or another. And then finally, I can select different images from asset catalogs. So I mentioned earlier that if you're not using asset catalogs today, you should be. One of the reasons is because it supports traits. It knows about the trait environment, and you can actually tell it to select different images based upon which traits are in play. Okay? And so we can actually do all of that. So let's look at size classes. This will be the last little demo that we do. And I have a starter application that we're going to begin with. And so let me just close this one and open this one. Okay, so here is our starter application. Let me just run it. I'm going to run it on an iPhone. Let's run it on an iPhone 6, actually. Give us a little bit more space. Okay, so here it is. Foodie.com, and we've got a nice little vegetable wrap here. It's a pastry. And you can see that we've got some size classes or some auto layout in play to be able to kind of control the orientation, and it sort of keeps things where they are. It all looks pretty nice. Everything is pretty good in terms of the display. Now, let me run this in an iPhone 4. Let's put it in an iPhone 4S. That's the oldest device that we can run iOS 8 on today. And so notice here, it looks exactly the same, but there's a few things about this that kind of bug me. One is, notice that the logo is relatively large for a relatively small display. In fact, it takes up half my image here, right? I don't really like that. That's probably not a great design. The other thing that I'm not really fond of is when I move to this sort of portrait or landscape orientation rather, really the layout here doesn't really make that much sense. What I'd rather have is the image to be over here on the left and have all the text on the right to have more of a scrollable surface that's a little bit more readable than this longer, kind of long lines that are here. And so we're going to use size classes to do exactly that. We're going to adjust this. So the first thing that I want to do is I want to change this so that my header bar there is actually smaller when I'm on the iPhone. Now, it turns out that this logo image here is quite interesting. If I go and I look at the image assets, this one's quite weird. So notice, come back. There it is. Okay. Notice that the logo itself just has one image in it, and it just says universal. And if you've not looked at Xcode 6, in particular image assets like this, asset catalogs, you might wonder, how in the world did that get accomplished? Well, if I switch back this got locked in, so if we switch back to here and actually, I want my properties for this. There we go. If I switch back to my properties, what's happened with this is the value that's actually been placed in here, notice there's a types thing here now on image asset catalogs, and we have bitmaps and we have vectors. iOS 8 now supports the ability to use vector-based images that scale. Yes. I no longer have to supply 3 or 4 or 10 or 12 different images for every single possible device capability. And so what I did is I created, if you look here, in my assets, I have just a PDF. So I use Sketch. If you're not familiar with Sketch, it's just a Mac program. It's kind of like Illustrator. It lets you do vector-based art. I exported a PDF. I then created a new asset in my asset catalog and dragged the PDF in here. It's a scalable image. I can then apply that image directly to a UI image view, as you can see right here, and it automatically scales to be whatever size I tell it to, right? With full fidelity, without me creating different images of different sizes. Love that. That's great. And so what we want to do is we want to shrink this. Well, it turns out if we actually looked at the constraints that were being applied here, the size of this header is actually based upon the size of the image. So really that's what's causing the header to be so big. And so what I'm going to do is I'm going to take this image and I'm going to go put a height and width constraint on it, and I'm going to make this 24 by 24 and add those two constraints. And then let's just go ahead and update the frames. And so notice as soon as I do that, that now my header bar is quite a bit smaller. But see, I made a mistake. Anybody know what it is? What size class am I in right now? Any. I just did this for every single device. Be very careful that you don't do that. So I'm going to use my friendly Command Z, and I'm going to go, oh yeah, I forgot. I should have done this in the compact, let's see, actually I want, for all compact width layouts, e.g. iPhones, I want width layouts in portrait landscape. So I want this one. And let's see. Ah, that's interesting. It's got a constraint on there. Let's go back to any. And any it's installed too. Oh, it's because I didn't do it. Let me reverse that again. That's why. We still have those constraints on there. So here's an interesting thing. Let me show you how to delete constraints. You might think that you could actually go over here, select the logo, and delete the constraint from over here. So you can see they're still here. I didn't Command Z enough times to delete it. But actually that won't work. In fact, you need to find the constraints over here in the document outline or click on them in the designer and then delete them. That's how to get rid of constraints. Okay? So let me remove both of those constraints, go back to all iPhones, and then let's put it back. So a width and a height constraint on this guy right here. There we go. Width, height, 24, 24. Okay, and then let's update the frames. That's what I want to see. Now if I go back to any, here for all layouts, we go back to our big size. So only for the iPhone are we going to shrink that up. Okay, if I run it, you would be able to see that. Easier way to see it is probably just through the preview. We can see the preview here and see that, sure enough, for the iPhone it looks good. If I look at the iPad as my other one, it's much larger there. Okay, so I've done just this for the iPhone. Now, I told you that we'd like to do some other pieces here as well. So let's start with the image. I'd like to have the image actually move over to the left of the display, but only when I'm in a compact height size. So on the iPad, I don't want to do that. It's fine on the iPad because we just have lots of space there. So any iPhone in landscape, I'm going to adjust just for the compact side for landscape. And we're going to take our image here, and what I'd like to do is I'd like to move it over to the left and have it actually take up the whole height of the view itself. And so let's click on our food image, and let's just look at the constraints that are here. We have a leading space to superview, so that's the left side. That's okay. We have a trailing space to superview. That's the right side. I don't really want that constraint. So what I'm going to do is I'm going to select the constraint here, and I'm going to hit delete. It looks like it's gone, but it's not. All I've done is I've removed it for this size class. So if you click all up here, you can see that it's still here, it's just grayed out. In fact, if I open up the constraints down here, you can see it's still here as well. Right? It's just grayed out in here. So when you delete constraints from the layout tab of an element, you're not really removing them at all, you're just removing them from that size class. They're still there. And so you have to delete them from the document outline if you truly want them to go away. So we don't want the trailing space to superview. Let's go back to this image, food image here. We have a top space to superview. That's okay. We have a proportional height to superview. So in other words, it's 1/4 of the space. I don't want that one. We're going to delete that. And then the rest of them are for the label. So those are all okay. So let's put our real constraints in here. Let's take our food. I want it to go down to the bottom. So I'm going to go ahead and say drag up to the view, and we want to the bottom space. But notice it's showing me the bottom layout guide. And even if I hold Option, it's not changing that. Well, the problem is this control drag doesn't give me the option of actually locking to the super view in most cases. The easiest way to get to that is through the editor menu here. And so I can say editor, pin, bottom space to super view. So this one always shows super view. And again, of course, because I didn't actually have it positioned there, it put 220 pixels in there, and so we're going to go ahead and lock it down. Let's fix our frames. So select TIE Fighter, update frames. Okay, now notice it's going all the way across because that's the size of the image. Now what I'd like to do is I'd like to actually do a proportional size width. So I'm going to say equal width, select my equal width here, which is food width is equal to super view width, and let's put in a multiplier of 0.45. Let's update our frame again, and now it shoots over to the left-hand side. That's where I want it to be, okay? Now let's play with this label. The label's kind of messed up here. If we look at the constraints that are on this, you can see that we have a trailing space to super view. That means it's locked on the right-hand side. Again, I don't want that one. Leading space to super view is okay. Top space to food, negative 75, so it's pulled up into the food image a little bit. That one's okay too. And what we're going to do is let's just put the label onto the image itself. And let's do a right constraint. Let's take the trailing end here and edit this one. And I'm just going to make it 0. And that'll lock it over to the right-hand side of this image. Now notice that it's on the margin over here and it's not on the margin over there. And so what I might want to do here is say negative 16. Oh, no, positive 16, sorry. In order to give me the same spacing on here. All right, so we can adjust that constant to kind of move it around. Now the other thing that we've got in here is the text view. This here, which was our text. If we look at this one, it's trailing space to super view, leading space to super view, bottom space to the layout guide, and the top space to food. Now it's not going to be on the food, so we're going to get rid of the top space. Bottom layout guide's fine. Leading space to super view is wrong. We don't want that one either. Trailing space to super view is okay. Instead, what we want is we want to take this text view. Let's put it on the right-hand side of the food. So I'm going to go ahead and use the left piece here. Let's pick that one. And what we want is food leading is equal to text view trailing. Okay, so we want to put it on the right-hand side. I'm going to put a constant of 0 on there. That'll put it right up against the edge. And then the other one that I want on this, if we look at the text view again, so we've got a trailing space, food, bottom space to bottom layout. I need a top space. Let's put it on the header. So we'll say on the top. And again, I'm going to select that constraint. And so text view top is equal to header top. I actually want it to be equal to the bottom. And I want that to be 0 as well. Okay, let's update the constraints and see what we get. All right, so that didn't actually position where I wanted it to. Did I do it to the wrong one? I bet I did. Let's see what we got here. So, and if we look, we actually have an error. So horizontal space, it says we've got conflicting constraints here. So text view, food, and text view are kind of messed up. And it doesn't know where the text view is supposed to be. So let's just look at what constraints we got here. So we have a trailing space to super view. That's okay. Trailing space to food. So that's food leading. That's actually not what we want. I want food. Let's reverse these actually and make it easier to see. So text view leading is equal to food trailing is what we want there so that it's on this side. And now notice it's no longer red, it's orange. So we just have some misplaced views most likely. And I hate that you have to deselect the constraints in order to get to this menu. It's kind of annoying. There we go. Update the frames. And there it is. Okay, so that one, it was reversed and it was kind of pointing at the wrong side, and so it kind of screwed up my constraints. So you can see now that the text is here. I might want to move it around just a little bit. So right now we've got the leading space to food. I'm going to edit this one and just add in a nice constant, say maybe 16, to kind of push it away from the image a little bit. We could do the same on the top if we really wanted to. The other thing that I'm going to do here is let's take this foodie.com, and what I want to do is I want to put it over here on the right-hand side. Okay, so I want to slide it to the right. But if I do that, it's not going to look correct just in terms of the header itself. And the reason why is because it's black, and this header over here is not black. And so that's a timer. And so what I really want to do here is I'm going to actually make this view go away when I'm in this size class. And so by selecting this and going to my properties section here, I can say uninstall this. So there's a little installed checkbox down here. I'm going to say uninstall this one, and I'm going to put a new label in here. And I'm going to drag it and stick it over on this side instead. Let's make it white. And let's increase its size. So we'll make it a custom font, Helvetica. Let's just make it 24. Done. All right, let's resize it a little bit. So this will be foodie.com. That's what we had before. Let's take it and actually line it up in the header. So I'm going to vertically align it, so center vertically. And then I'm also going to go ahead and drag it over to the edge and say let's put a trailing space to container. And so that way it'll sit on that right-hand side. Okay, we could make it centered inside this piece as well if we really wanted to. The last thing that's in here that's kind of annoying is there's a little separator line down here at the bottom. I don't know if you can see it. It's a little green line there at the bottom. I actually don't need it when I'm in this orientation. So what I'm going to do is I'm going to go to this separator line, and if we look at its constraints, it's got a height equal to constraint on it. What I'm going to do is I'm going to double click on this to edit this constraint, and notice that there's a plus next to the constant. When I click the plus, I'm adding in a specific variation for this size class. And so I'm going to say for this size class, I want it to be 0. All right, in other words, I don't want it to display. No height means it won't actually show up. Let's run this and see what it looks like. So this is iPhone 4, which should be one of the devices that we do this with. So we can see we've got a smaller view here. I'm going to rotate this, and you can see that everything moves around the way I expect it to. Although we lost our foodie here, so that's a problem. Now, one thing you can do if you want to see the animation, so you asked about animations, you can toggle slow animations, and you can see exactly what the system does as it kind of moves this. So you can see it's kind of shifting things up, and the line is actually animating in. So it automatically applies animations from these constraint changes going from one size class to another. The system does that automatically, but you can influence those animations if you choose. Okay? Now, the other thing I wanted to show you here that I think is interesting, and then we're out of time, so I'll stop, but is changing images. So I mentioned that you can actually change images as well. So if you go to your image assets, so I'm just going to drop it in here. So notice that we have a food asset that's here, and if I open up my properties, we can see that its width is any, its height is any. So over here in the Property Explorer, there's actually a width and a height. I can say if the height is compact, all right, so if we've got any height and a compact, then what we can do is we can actually change this image so we can make it look like something else. And so let me drag in just a different image here. And so this will then let me adjust this for any combination that I have. So if we said this direction as well, let's put in a couple more. So we'll just drag this one in, and I don't have another image, so we'll just drag in Sherlock Holmes, because who wouldn't want to eat that? And then when we run this, you can see that we get the different food there and Sherlock Holmes when we move into the compact. Okay, so based on those images, it's going to shift them in and out based on size classes. And the system will just automatically handle that. So you can see that we're getting different images as we move back and forth. Okay? All right, so that was kind of a quick overview of auto layout and size classes. And they really kind of work together to be able to do the job of adaptive layout in iOS. Now the big question is, should you use it? Well, it depends. This is only available in iOS 8. So if you need to target older devices that are incapable of running iOS 8, none of this stuff is going to apply to you. You can still do it the old way with different storyboards or do it in code. Or perhaps maybe you work on enterprise apps where they're late adopters. iOS 8, by the way, by last stats anyway, is on 80%.